do need your full attention. And I am starting recording. David, I'm going to wait for everybody to quiet down. I need everybody's full attention for the next at least hour. And so we're going to go ahead and get started. Yeah, I told you some of these lessons are going to be intense. This one is one of the ones that I would consider intense. However, if you pay careful attention to the strategies I give you, hopefully won't be too terrible. And we're doing redox today, at least mainly the oxidation part of redox. And you know, your favorite is redox, right? Remember that from the class? We did it in the inorganic section of the class. Leo says GER, lose electrons, oxidation, gain electrons, reduction. We're doing redox today. So, but we're not doing math. So we're going to look at redox as a biologist or an organic chemist sees it. And that'll be the reactions we're covering. First, let's do the bell work because I don't know if anybody got 5 out of 5. I can't remember. But there were some students that got 4 out of 5. Type of polymer. This is asking if it's addition or the other type. We only know one type. It's addition, meaning it adds to itself over and over and over again. Yeah, so when they say type of polymer, that's not the name. So if you said hextuene, that's not it. It's asking type. Type is a different command word. They're asking you for something specifically. What type of polymer would this be? We only learned one, so there's only one answer for that. Draw one repeat unit. Last class I taught you a method to do this. I noticed most of you did not use that method. I did. The method was the following, just to repeat. And remember that homework's due tonight, the one on addition polymerization, so make sure you're completing that. There is homework due tonight from last class's lesson. And that's just to give you time, if you had questions on the homework, to resolve them with me before you submit it. So my suggestion on how to do this is look at the 2 carbons where you have the double bond and start there. I suggest actually drawing them out and not doing it skeletally, but you could do it skeletally and get the correct answer. But I suggest doing this. C double bond C. Start with that. Then look at this carbon and see what it's connected to. Because remember, you're supposed to have 4 total groups. What is the carbon on the left connected to? A CH3. So I can either write that on the top or the bottom. It doesn't matter which one. So I write a CH3. And what's the other thing attached to this carbon? Hydrogen. And so I write a hydrogen. So far, so good? On the other side, I have this part. What's attached on one end? And is this cis or trans? It is, isn't it? So I think you should write it one on the top, one on the bottom, right? And then we have on the other side a hydrogen. So far, so good? I'm writing it like this to prepare you for what you need to do. In order to get the repeat unit, what are you supposed to do? Do you remember? Break a double bond. So basically erase it, right? It's gone. I'm just going to show you if I were to erase it, which you're not allowed, unfortunately, to write in pencil in the Cambridge exam, but it would be so nifty if you could just erase that. Do this. Brackets and answer. Right? Oh. Did you see what I did? Yeah, but you should know this. So you could visualize that if you know what to do. You're breaking the double bond, you're extending out, and you're writing the little F. What is the directive that tells you you need to do that? What is the directive that tells you you need to do this specific thing, Justin? 1 repeat unit. So you may want to write a box or circle that. That's the important instruction. That you said, oh, repeating means it goes over and over and over and over again. So the addition happens at the alkene and it's adding to it stuff. Continue. 2 points. One of them would have been for getting all the groups correct, and the other one is for the dangling bonds in the end. So if you had all the 4 groups identified correctly, like where does it polymerize? Around which 2 carbons? Because down, up. That's the trans version of this molecule. This is trans hextuene. All right, next one. This one was, I don't know. Yes, at least one person did get this right. But I expected this one to be difficult. I included it for a reason, because I want you to analyze different situations. This says you have a halogen alkane that is C5H11Br, and that it cannot make an alkene. It cannot make an alkene when treated with sodium hydroxide and ethanol. So the key here is that no alkene can be made by whatever the formula you are looking for is. And so they give you options. What could it be? And when I was looking at it, I just figured to start where you have the most stuff going on, which is actually D. Draw it out any way you like, but I'm going to go ahead and draw it out. It's propane, right? So C, 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 right? Then on the second carbon, I have a methyl on the top and a methyl on the bottom. On the first carbon, I have a bromine, and then I got this, and this, and this, and this, and this. And I think I had taught you, when we did elimination, I'm sure I did, last class, you take away the bromine from one carbon, and what would you take away from the carbon next door? A hydrogen, right? Well, what about the carbon next door? What's the problem? There are no hydrogens to take. If you cannot take a hydrogen away, you cannot take the bromine away, because you cannot make the HBr and you cannot make the double bond. Think about it a different way. If you were to put an alkene here between these two carbons and you went C double bond C, 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 what have you just done? You did the one big sin for organic chemistry. You can't have a carbon with 5 bonds. And which of these carbons are you deciding to kick out, given that this is a completely, like, it's now polar, right? It's not going to happen. None of these carbons are going to leave. And so this is a big, nah, that's not happening. So it's not happening. So they're asking which one does not make an alkene, and the answer is D. And the whole reasoning behind it is because you can't pull anything off of the carbon next door. You have to, if you're making an alkene, you have to do this. You have to have this with the X and the Y, where you can pull this off to form this, right? This has to be able to be pulled off like that. And you had nothing you could pull off that carbon. Is that okay? The explanation. It was a difficult question, to be sure. But a couple of you did get the right answer. So
you can't pull off methyl, right?
You can't pull off a methyl. You can't pull off a methyl. That's why. It's a hydrogen you pull off. Any other questions about this one, or we're good to move on to the next one? All right, this one was scored fairly well. This was similar to one of the questions that's on the homework due tonight, so I wanted to address it. It was addressed to me during tutoring, and I had intentionally put one in the homework that was kind of difficult. And so the same idea is discussed here. And so this asks, it gives you, they're hitting you with those fun facts again. The molecule limonene is found in lemon and orange oils. So this is responsible. It's in, if you ever have like on the skin of an orange where the oil is, if you've ever tasted that, or if you've ever tasted lemon oil, there's some limonene for you. And they ask you, when limonene reacts with an excess, and I want you to underline the word excess, because I had not addressed this with you in an earlier class, so I wanted to make sure that this was addressed. Excess means the following. The reaction can happen more than once. Wherever the opportunity to do the reaction is available, it's going to happen. So this means that reaction can happen more than once. What do I mean by that? If I were in a future mini assessment to give you plus H2 in excess, what would your answer be? Both of these double bonds would disappear and hydrogens would be added and it would be hexane. Does that make sense? So you may want to write this down for yourself because it's an important idea to keep track of. Now for this question, what does this mean? HCl is what we're adding. So a couple of things going on here. First thing you got to remember is HCl adds to the what on the molecule? The double bond. The double bond. So it's going to add here and it's going to add here, both places. Now you got to remember Markovnikov's rule and the inductive effect. So wherever the carbon with the most stuff going on is, that's where you're going to put the chlorine. And this one would also be the other chlorine. And which answer does that match?
Right, so if they say minus product, then it would be neither.
Right, if they ask for minor, which is very unusual. They almost always ask for major. But if they did, you would know it goes to the other one. All right, good? Understood? Before moving on, I just want to bring something up. In the analysis that I've done of the different papers, paper 1 each year, questions about 25 to 40 are organic chemistry. Meaning 15 out of 40 questions on the paper 1 are organic chemistry, which is why I said if you don't cover organic, you're in a bad place, because out of all the units of study, it has a lot of questions on it. The average passing score for an E on a paper 1 is somewhere between 13 and 15, by the way. Out of 40.
You could just pass with this.
And then bubble in the, yes, technically. Whereas in some of the other units of study, like enthalpy, just to be honest with you, enthalpy and rates of reaction is about 4 questions out of the 40 on an average Cambridge exam. So the reason I'm telling you this is because this portion, not only is it hefty on paper 1, it can be up to a third of the points at least on a paper 2. You could get 20 out of 60 marks on organic chemistry. So just to keep our focus, there's a reason why I'm a little bit stricter in terms of having many assessments each class and stuff like that, making you practice over and over again, is because I know how heavy this is weighted on the actual Cambridge exam. And I want you at the end of the day to be very successful and for everyone to pass. So you've got to put your part in though. You've got to study. I've given you flashcards. I'm coaching you each class. I'll be giving you additional techniques as we go through. But this is a unit you can't goof on, is the way to say it. You can't goof here because this is one that's going to be a major play for the end of your exam. You want to make sure you know this stuff quite well. And we'll practice it a lot. That's why you saw that I gave, I think, 6 weeks in the schedule to just this unit to give that time. No worries. All right, so here we go. Objectives. Our lesson today, redox, but specifically oxidation. The main goal, if we can understand alkenes and what to do with those, that actually finishes the part of the unit on reactions of alkenes. We'll finish that today. It makes logical sense to also include the oxidation of alcohols in the discussion, because when you see what happens with alkenes, you'll see they're actually almost the exact same reactions with alcohols. So it's better to teach them together, I've noticed in the past. If we run out of time, I have a whole nother day set aside in our schedule to do alcohols, but I'm going to try to get both of them done today so that it could be done together. Like usual, you've got a mini assessment. It's on the schedule today for 2:05 p.m. If we finish a little bit early, I'll give you time to do your little cram session to mentally do that. But there are some certain things we have to go over today that are very important. Finally, before I give you the mini assessment after the lesson, I'm giving you the lesson for next class. I printed out the lesson for next class. Remember, I'm not going to be here on Tuesday. I've already recorded the ed puzzle. It's uploaded. It is going to auto post. So you'll be able to watch, answer questions about it, and then answer them in your notes and do your flashcards for next class's lesson on Tuesday. All right, so here we go. Breathe in, breathe out. Let's see what we gotta do. Our learning objectives. We are wrapping up with this. We are done with alkenes once we finish this. We're done with everything Cambridge wanted us to know about alkenes after these objectives. So describe the chemistry of alkenes as exemplified with the following reactions of specifically ethene, but could be applied through any alkene. As you've seen in many questions, they're not just giving you ethene, are they? You're getting limonene from the Bell word. So oxidation by cold dilute acidified. So here's where it says acidified, and you could just use H plus because it doesn't say what acid, so you can just write H plus. Manganate 7 ions to form a diol. Oh, what's manganate 7? Ring a bell? Is that a polyatomic thing? Is that a thing? That's MnO4 minus. You may want to write that. What's MnO4 minus? To form what we call a diol. What's a diol? That's a double alcohol, right? That's a double alcohol. That's the first thing. That's the easier of the two reactions. The second is the harder of the two. And this one is going to be the one that you need to pay careful attention to how I go over how to teach it, because I'm going to give you a strategy that you can still do all your flashcards on it, but if you understand this strategy, you'll actually be able to predict all the possibilities of what's going to happen without like 5 to 10 different flashcards for it. So here's the second one. Oxidation by hot concentrated acid, and then MnO4 minus. So a little bit annoying thing for you is that there's actually going to be a completely different product if you have cold KMnO4 versus you have hot KMnO4. But maybe the reasoning will make sense. With cold KMnO4, you're only going to break a pi bond. But if you heat it up real hot, you got hot acid, you heat it up real hot, you'll break not only the double bond, but you'll also break the single bond. And so that's the difference between the two. And I'll go over that when we go over it. And then finally, if we get the time, if time allows, we'll start talking about alcohols because the products of the oxidation of alcohols are the same products as the oxidation of alkenes. So that's why I wanted to include that in there because it's the same ideas that apply. And so I try to group things together that are similar so that you don't have to think of it as memorizing a bunch of different things. So here we go. Organic redox review. Just remember, what is reduction, what is oxidation? When we talk about oxidation, we're talking in biology and organic chemistry terms, which was the first way oxidation was presented. They didn't know about the loss and gain of electrons when it was first presented because they didn't know about electrons. Like, they didn't know electrons were a thing, actually. So the original definition before was that oxidation is a chemical reaction where whatever molecule you have gains additional oxygen atoms, or the opposite, it loses hydrogen atoms. So gaining oxygen or losing hydrogen, we call that oxidation. The symbol you see for this is O. And this means we are not specifying the reagent. So if you're allowed to not specify the reagent, you use the letter O. And that just means provider of oxygen. Whatever you're doing is oxidizing your organic molecule. We're going to talk about your reagent today. You saw it. It said it was permanganate, right? Potassium manganate 7. That is what is going to be the main reagent. Yes. Yes, it is. In organic chemistry, some wording changes a little bit. Reagent and reactant are the same thing. Reduction, loss of oxygen. So the word reduction comes from, it's the opposite of oxidation. Like redox is always opposite process. So in a reduction process, your organic molecule loses oxygen atoms or gains hydrogen atoms. The opposite again. And the symbol we use for reduction is hydrogen. This once again is if we are not specifying use just H, it means we're not telling you what it is. You are going to learn what the reagents are, the proper reagents for oxidation and reduction. And there's really easy ways to know them that I'll explain. They stick out in the grand scheme of things. So, first of all, redox, you don't have to do numbers, no math. However, if you're a math person, you could calculate the oxidation number of every element in every compound and figure it out. That it's a reduction or an oxidation. The strategies that we used before actually still apply. You just don't have to use them because they'll be technically, for people who don't like math, easier ways to figure it out. All right, so here we go. Example of an oxidation. This is an example of an oxidation reaction. This is an alcohol, and this is a slide from earlier in the year when we did example reactions, just showing what it was. What happens here? This is ethanol, so I'm going to draw it out, displayed for the win on these processes sometimes. So when I explain everything, I am going to explain it in display so that you see what's going on. When you go from the ethanol to here, what does CH3 show? What is that? Nope. Carboxylic acid is COOH, it's an aldehyde. That's this. Aldehydes have entered, they're entering the conversation today. Aldehydes are entering the conversation. When you go from ethanol to this aldehyde, what has happened? Trace what has happened. Atom-wise. What have you gained? What have you lost? Have you gained anything?
H.
You've lost an H.
And you gained it a little.
Well, how'd you do that? You lost another from specifically. And what happened when you removed two atoms from two neighboring places? You would put a double bond there, and guess what's there? And it ends up being an aldehyde as a result. So this is removal of two H. And does that sound like an oxidation based on the basic definition? Basic definition of oxidation is you either gain oxygen or lose hydrogen. Because the exact reagents aren't told to you, you won't necessarily know why this is the exact product. However, most of the time, you would be asked for the major organic product, and water is a byproduct. Okay. Cheer down. Water is a byproduct. But if you want to remember how that happens, oxygen to hydrogens make water. All right, so we use O if we're not specifying what the reagent we have that's doing this is. And because the reactant molecule ends up having less hydrogens on it, the organic molecule has been oxidized. Yes? That's why I said you won't really know. There's two H's here, and then the other oxygen comes from here. Because this has, whatever this is giving oxygen to everything. Like, this is just a giver of oxygen. It oxygenates is another way to say it if you were using biology terms. Oxygenates and deoxygenates, right? What? Not anything. We're going to see specific things today. Yes, Ben. Go ahead. All right. So just to remind you of so these first slides are just reminding you of the type of reaction, what we're looking for. Take a look at this reaction. What is your organic reactant here? What's that? What's a functional group? Count your bonds carefully. CH3, C, double bond out. It has to be. It has to be, or else you'd be saying this carbon has no hydrogen. It's a ketone. And so what are they telling you here? Whatever you have is giving two hydrogen. We don't know what this is. We just know it's a giver of hydrogen. We have not learned exactly what they are yet. That's another day, another lesson, because really we're not going to be going too much over reduction today, but just to know the process. So where can hydrogen be given in this molecule? There's literally only one place. At the double bond, right? here and give one here. And guess what that gives you? An alcohol, which I probably should have put the parentheses on. So you could add those parentheses. CH or COH and H. Do you see how that happened? Hydrogen's added across the double bond. So isn't this very similar to alkene addition? Instead of adding across the double bond of an alkene, you're adding across the double bond of an carbonyl group. So you add across the C double bond O. So you get an H on one side and an H on the other. That's the idea of a reduction. Now I told you we're really not going to spend time much on reduction today, but you should be aware that oxidation and reduction are opposing processes, meaning that anything you oxidize, you can go back and reduce. They're opposing processes. And you'll see that in the lesson today with double arrows. That's why I wanted to bring up what both work. All right, kind of got the ideas of what's going on with oxidation and reduction so far? So let's apply them to alkenes. I know, yeah. So here's the first reaction, and I do have, I've been redoing the slides this year to like try to be more clear about the flashcards. And I was just like, most of this lesson today, you skip forward, it's just a bunch of possible flashcards to write. So the first reaction that you got to know today, and I gave it a name so that you would know what to write, is the oxidation of alkenes with cold KMNO4. And the key words are going to be cold versus hot, because there's something different going to happen. And so the reaction is this. You've got your alkene, and you've got KMNO4. This is your giver of what? What is KMNO4 giving? What does it have a lot of to get? Oxygen. So it's going to oxidize the alkene. It's a giver of oxygen. And what is the clue? Like, what is the literal clue you could look at in that formula that tells me, yeah, this is oxidizing, not reducing? Nope.
Wait.
If it's giving oxygen, what is the clue that KMNO4 is giving oxygen? There are lots of oxygen atoms in KMNO4. So anything we consider to be an oxidizer is going to have a lot of oxygen. So look for lots of oxygen to know that it's oxidation. And so then what is the result? When you have KMNO4, you have acid, which we're going to just call H+, right? And cold. What was the other word that was in the directives that we should probably be aware of? You should probably add the word dilute. What does dilute mean? It means, what does dilute mean? What does dilute mean? Dilution of solution.
With water.
Dilute means not concentrated. It means the opposite of a concentrated acid. A concentrated acid is lots of acid, little bit of water. A dilute acid is lots of water, little bit of acid. That's the idea, yes. Oh yeah, you can use this as your example for the flashcards. I just wanted to organize thoughts a little bit clearer. So what I was going to do is give like an example of what you could do here. Oxidation of alkenes with cold KMNO4, but you could totally just use this reaction. So what happens? C, double bond C, and then you've got, what would you put on the side? It doesn't matter, right? So X, Y, Z, W, is that what we came up with? No, not W. We came up with Q. Q's not on the periodic table. Technically Y is on the periodic table, but I'm just that. Not yttrium. Everybody forgets about 4 yttrium. I had a student 1 year for spooky science. We did a competition where the student had to name as many elements as possible off the top of their head, and the one that got them was yttrium.
Really?
Everybody forgets yttrium's the same. Anyway, here we go. We got this. main thing you're looking for. And here, I mean, you could use colors or whatever. You know, you still got your X, Y, Z, Q, whatever those groups are. What's new? On each side, you've now got N, O, H. So I'm going to use a different color. Blue. OH and OH. This is called a di. Oh. Could be anything. You choose whatever letters or symbols you want. Doesn't matter to me. The idea is that notice how they did it in the image I found online? They just did a line going to anything, but they left it blank. So I mean, you could do it like that, but then you could just think, oh, it's always methyl. Because y'all did that with polymers. You thought it was always ethene. No, it's not always ethene. It's whatever these are. They are that. The important thing that's happening is the double bond breaks, right? Specifically the double bond breaks. And you're adding double alcohol. Would you want a flashcard for conditions? I would say you would. And you could use this as an example reaction, or you could use something else as an example reaction. But at least for the minimum, I'm having you write one flashcard down here. So I'm going to give you some time. Write this one flashcard. If you want to, you can make another one with the conditions. Would be dilute H plus KML4. And doesn't have to be K. Notice in the standard, they said, Cambridge said, MnO4 minus, right? Why am I writing K? Probably should be writing MnO4 minus. Why is K written? Because it's the easiest to access. If you recall from the lab that we did with KMnO4, the purple one, that's typically what we use. But does NaMnO4 exist? NaMnO4? Does LiMnO4 exist? Are there other permanganates with? Sure. So the important part is here, the K is actually a spectator ion. Whether it's there or not doesn't really matter. That part's the important part, that you have it oxidizing. So conditions would be what specifically again? Just to be clear, dilute H plus cold, right? I mean, it says cold there, but that's the thing. It's cold. And then MnO4 minus, to be clear, it could be any spectator ion. You need a giver of oxygen. All right, I'm going to give a little bit more time if you're writing down. You can either write down here and transfer to your flashcard later, or you can write directly on your flashcard. Yes. Yes, you may. What?
You took my matchbox.
Do it.
Yes.
So H plus, I don't know, 4 minus.
So this gives the oxygen, this is the catalyst, and cold is a condition that allows you just to break the double bond and not the single bond. If it gets too hot, you'll break both bonds, and the whole thing will split apart. Yes. Okay. It happens. All right, you're gonna notice on the next slide it says practice questions. Just because I want to take breaks to do practice questions, so you'll see a couple of practice questions after this. I'm giving a little bit more time. I'm looking to see if you're writing down on your flashcard still, or you're writing down the notes here on what you should be putting on your flashcard. This is the first time I actually did like what you write on the front, what you write on the back. I just told the other years, like last year, like just make the free flashcards on this.
What is that?
All right, I'm moving on in about 20 seconds. You ready to see some practice examples? So how would I write it on your mini assessment for, you're not gonna have one for, you're gonna have the one today, but this lesson won't be on it. So the next one isn't gonna be until the Monday of like, not next week, but the week after, I believe. So you're gonna get a week break from mini assessments after today. Ready? Practice questions. Here we go. plus KMNO4, because I always have to write that. H plus cold AQ. What's the product? That's five. That's five. Is it penta? It's 10. What are we doing here? What's the goal? Is it pentanol? Is it just pentanol? Yes, go ahead, just not too far, close though. Because remember, you always add right here and right there. It has to be on the 2 carbons of the double bond because you're literally breaking that bond, and that's where the 2 OHs would get added. So let's go ahead and take a look. I'm going to write the color. It is the OH here and the OH here, and that would be 2,3-pentanediol or pentan 2,3-diol, right? Because it's a diol. There's 2 alcohols. So whenever there's 2, you would say di of that. So it's pentan 2, 3 diol. You know how there was dimethyl and diethyl and dibromo? I mean, we did that this year. We did it in pre-ACE, but we did it this year too. Yeah. Yeah. Because I don't want to write the word dilute. When we're lazy, we just, write the AQ. Means in water. All right, next one. Plus excess. Excess. Right? Remember that thing I just talked to you about? KMNO4, H plus, AQ, cold. What does this do? You have to name it. It didn't say you have to name it. You have to give the product. Give the product. 6. 1. What? 5, 6. That's not a carbon. That's just my terrible drawing. Oh, sorry. Oh, it's because I keep on. I count the middle.
It would be 1, 2, 5, 6.
Okay, so it would be
1, 2, 1,
1, 2, 5, 6.
2, 3, 4, 5. 1, 2, 4, 5. Because
Oh.
1, 2,
Okay.
3, 4, 5. Right? All right. What's our
I
product
was
here?
confusing it with octane.
the one
because it's, why would you
Stick
put
an
this
OH here. Stick an OH here. Right?
We're saying more than one with the OH.
Stick an OH here.
Oh,
It's
Stick an OH there.
So it's at 1, 2.
Oh, there you
so
go.
start
All right. How we
with
feeling?
1, 2. Where's cyclo?
So double OHs. So
Cyclopens.
cold KMNO4, double OHs. It's an addition. So everything we're doing today is still addition to alkenes. It's just there's some more stuff to know. Yeah.
You know, put cyclo.
Oh, if I wanted to name it, it would be 1, 2, 4, 5. Cyclohexanediol. If I wanted to name it, that would be the name. I don't think
It would still be
Cambridge.
diol?
Sorry, it would be tetraol, right? Like tetramethyl, it would be tetraol. But you are not. Cambridge would not ask you to name that.
2, 3, 6.
1, 2, 4, 5.
Right.
Cyclohexan, tetraol. Would that be on a Cambridge test? No.
diol is sort of one top.
So it's cyclopentane. 1, 2.
4, 5. No, it would be cyclohexan 1, 2, 4, 5. Tetraol. Yeah. Not on the test. Don't care. Moving on. That would be the naming strategy. Only in pre-ACE do we go that deeply into naming. By the way, we go harder into naming in pre-ACE. The naming in ACE is significantly easier. But you get all the reactions. So here we go. Now breathe in, breathe out. Hot KMNO4 is a beast. So I need you, this is where I said you need to pay careful attention because what you read, I know that when I first read it off the textbook, it didn't make any sense to me. So this is literally what the textbook says. When you have hot KMNO4, the double bond of the alkene breaks, you get two products. If at the end of your double bond you've got CH2, that becomes CO2. If at the end of your double bond you've got CH3, that becomes a carboxylic acid. And if at the end of your double bond you've got two methyl groups, that becomes a ketone. Now, what in the world does that mean? What is going on here? So let's talk what. Okay. Oh, and here's another way to look at it. These are the products that you're looking for. Yes. Go ahead. As soon as the pass is back. The pass is not back yet. Now it is. Welcome back. All right, so yeah, you can make flashcards, and I do have flashcards for you to look at, but I need you to pay attention to method, because if you pay attention to method, this is going to be simpler than just memorizing a bunch of flashcards. And so pay attention to method, and if you need to make flashcards, then do so, but method is going to be really, really important here. There's a couple of things you need to know. First off, the idea of what happens is that when you have hot KMNO4, the carbon-carbon double bond breaks completely, like that. So in every single one of these situations, if it's hot, which you didn't say in these diagrams, but that is what's being illustrated, and we would have to state so, the whole molecule breaks into two smaller molecules. So far, so good? Now I'm going to show you from scratch how to do this. You see these blank slides? That's for me to show you from scratch how this happens. You ready? So, how? How though? So how though? This is going to be super important. So pay attention, write it down into the blank slides you have. The blank slides are 15 and 16. So I'm going over how though, and then we'll go back to what the expected products are. Here we go. So we're going to pick scenario number 1. You've got this. C double bond C, CH3, 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 and CH3. So far, so good? Scenario number 1. We are adding what stuff to this? KMNO4, H plus. And what's the other super, super important condition we got to mention? That we need to mention? Hot. I mean, like, if I were on a hot plate, probably like 80 degrees, 70, 80 degrees Celsius. Maybe even 50, 60 would do it. Which translates to about 150 Fahrenheit. Below boiling point, but significantly hotter than normal. Like a cup of coffee that could burn you. Yes.
How did we get H3O plus here?
Oh, goodness, that's a good question. I didn't mention it. Whenever you see H3O plus is H plus. What? In Greece, we did a little bit of studying on acids and bases, and it turns out that the strongest acid that can exist in water is H3O plus. So in water, all acid exists as H3O plus. So if I technically put HCl in water, it exists as Cl minus and H3O plus. The hydrochloric acid transfers its H plus to the water. Now, if you don't understand this and you don't get this, don't worry about it because that topic's taught later this year. But the important part, because that's in our final unit, but the important thing to note here is that if you see H3O plus, it's the same thing as H plus because it's water with acid on it. Acid has to be acid in water, so it's the same thing. So you could, for like, I'm ignoring this and I'm gonna write this as H plus because I don't wanna confuse myself. So every time you see H3 or plus, you're allowed to go change that to H plus. Good with that? So that's acid. It's just, it's acid. It's a great question. Once again, I have not taught this to you. In the previous class year, I did teach Bronsted-Lowry theory. You may recall proton donation and like acids give away H plus and bases receive H plus. That's what this is. But again, I reteach this in unit 7. So if you don't remember it, don't stress it. H3O plus equal H plus, just to know. Great question though. How are we gonna write it though? H plus. Now, what did I say actually happens? Like, what's the thing you gotta know? If it's hot, both the single bond and the double bond breaks. So visualize this by breaking the double bond. And here's what I want you to do. Rewrite this as 2 molecules. CH3, C, CH3, plus, I don't know why I think about this. Any of you Star Wars fans? I feel a little bit. Okay, so the way I visualize this is, and maybe you're a sequel trilogy hater, and that's okay. But the way that I envision what's happening here, just to give you an idea, is when Kylo Ren and Rey are fighting for the lightsaber in Episode 8, and they both like are pulling on it, and it goes in 2 separate directions and breaks in half. That's literally it's breaking into half, right at the middle. Do you see that? So we break it into 2 separate products. But then you should say, hey, Miss Lee, this don't make no sense. We can't have electrons going to nowhere. What is the process called again? What is this? This is oxidation.
So it adds oxygen.
So adds oxygen to each side. So where the double bond got broke, you add a oxygen here. So I'm gonna write in a different color, and an oxygen here. Your result is ketone. Yeah? Do you see?
Yeah.
Ketone. So you just took an alkene and threw it into a ketone. And this one's also a ketone. All right, so that was scenario number 1, which is technically the simplest scenario.
So that happens when there's hot water.
Hot KMNO4, because you need the provider of the oxygen. Without the provider, without the oxidizer, you can't get the oxygen there. So if you just have the H plus, it ain't doing anything until you got the oxidizer there, which is the oxygen. All right, that was scenario number 1. Like I said, if you pay careful attention to how I do it, you won't have to memorize a bunch of flashcards because you'll understand the process. All right, we're gonna try this again. So, scenario number 2. CH. Let me do red again. Red and blue. Oh, it's Jedi and Sith. I'm gonna start with today's picture. Right? Red, Sith, blue, Jedi. Anyway, I don't know if y'all knew I was a big Star Wars fan. So big, I missed school to go to a convention in Chicago in 2019, where they had a Star Wars celebration dressed as Jedi. It was super fun. And not the nerdiest thing, but one of the nerdiest things I've done. All right, scenario number 2. You got this. Same reagents, right? It's just what's on the double bond that's going to matter. Like what the different groups you have on the double bond is what's going to matter. In the first one, we had all methyl groups, and now we see if we have all methyl groups, we get ketone. But you can just remember the process of what happens and then recognize, oh yeah, that's a ketone. So far, so good? All right, here we go. Break this bond. KMNO4, H plus, AQ, hot. Here we go. What happens now? CH3, C, that, H, plus the other side, copy paste, but you split it, right? So you have this. What do we now add? We add oxygen and oxygen. And this gives us what's called an aldehyde. However, aldehydes don't stay aldehydes. You can add an additional oxygen, so pay careful attention to this. Whenever you have an aldehyde, it's actually always going to be further oxidized. Aldehydes will always become, and you're going to want to write this, aldehydes always turn into carboxylic acid in oxidation processes, meaning they very easily add an additional oxygen. So where would I add that additional oxygen? So this would be your final product. Yes. Hold on. So now you know that hydrogens turn to OH. So far, so good? Yeah, go ahead. Hydrogens turn to OH. That's why you see me doing it in different colors. I can't add to a methyl group, but I can add to a hydrogen and oxygen. I get an alcohol. Now, let's take a look at scenario number 3. But beforehand, I want you to look back at these example reactions. Take a look at this. Does this start making a little bit more sense? Look at the second one here, which is similar to the one I just wrote. They just literally told you this is a carboxylic acid and a carboxylic acid is your product. It's because we added the oxygens here, and we also added them here. See that? They don't stop at aldehyde, they go straight to carboxylic acid. And so let's look at scenario number 3. Ready? Scenario number 3 is going to recall something you learned a while ago in Unit 3, because everything in this class is really linked. So here we go. Third scenario. You've got C double bond C. And let's say you've got this. CH3, CH3, H, and H. And same reactants, right? Plus KMNO4. Hot. Cool. KMNO4. So far, so good? Okay. So we go through our strategy. We're like, this. We know now that I realized I had a feeling going class or not, and I was like, oh my god, they're repeating what I do. Like as I'm thinking. Sorry about that, guys. So here we go. We break this, right? We do. I think it was my 4th period. Get this. We got this. We got this. All right. From the last example, what did we learn? In the last example, what did we learn?
That the H, they all bonds to it.
That means you get this, and this, right? Okay. So here's where this right here is a ketone. Do you agree?
Yeah.
Ketone. And take a look. I got 2 hydrogens here, right? I got 2 hydrogens on this example. What did they say it actually becomes?
CO2. Carbon dioxide.
Is that what we got?
No.
Count the atoms. How many hydrogens is that? How many carbons is that? How many oxygens is that? And H2CO3. Did we learn something about H2CO3 back in
H2O.
It's H2O, which is already there, so they're not writing it as a product. And CO2. So memorize that process. If this works for you, it can actually solve pretty much any of these questions if you understand the process. So the process is you split the 2 carbons at the double bond, you throw oxygens on each side, right? You're going to get 2 products. If you get a hydrogen as a side group, you have to add an oxygen to it. Those can be further oxidized. And if you get this specific thing, it's actually carbon dioxide. That's why I said when I first read this in the textbook, I was like, excuse me? no comprende. But now that I've explained the process, it will make a little bit more sense what they said here. This would become, that becomes CO2 because of what you make. All of that. Yes? So that's where that comes from. Okay, so if this process was difficult for you, guess what you can make? Flashcards. But how many would you need to make?
4.
At least 3, because you need one for every different type of scenario. So you can go do that at home if you want, but I gave you a different method if you don't want to put these on flashcards. Take a picture now if you're going to.
I mean,
I wonder where your phone could possibly be. I mean, it could be anywhere.
All right. We're gonna before we move forward,
has a good point.
we're gonna look at some more examples, just so that we can practice what I just taught. What does this look like? So again, flip slide. This is Miss Fleet saying, more practice. More practice, more better. All right, here we go. The next slide, you can do practice questions. Yeah. So, practice. I didn't title it, but I anticipated to do practice. Let's start. So you'll be asked cold can metaphor versus hot can metaphor, and you'll be asked for that in your homework for sure. And in the mini assessment a week and a half from now, because the next is actually a week and a half from now, this topic will be included. Yeah, so next week I'm not giving one because I'm out on Tuesday, so I don't think it's fair to test you on something I wasn't physically here to teach you on, even though I'm doing it on that puzzle. It's not quite the same. You need to be able to ask questions. So here we go. Practice number 1. Let's see if we can have some fun with this. We'll start pretty simple. H plus, AQ, hot. We're going to practice hot now. What do? See if you can come up with the product. You can beat me. You feel comfortable with it. And you're like, why are you trying skeletal? Because skeletal easy. You can fill in the hydrogens if you want.
We can do a display format too, right?
Absolutely. And you'll see when I prove the answer, I'll have to fill in those hydrogens to prove why it is what it is. All right. Giving you a little bit of time, think it through. It's a keep on. See if you can come up with it. So is this how your the question of the mini assessment for this would look? Now you're going to get the idea of what a lot of questions look like. Lots of memorizing. Okay, so my method is to like literally go and then break it there, right? So I get this and this. But now I know that at the end of these double bonds are no longer carbons, they are oxygens, right? So far so good? This is a ketone. So I know I got the one product. Well, what is this other one suggesting? Just adding the oxygen. What else is here? That carbon only has 3 bonds and it's supposed to have 4 bonds. So that means this one has a hydrogen. It's an aldehyde. But aldehydes don't stay aldehydes. That hydrogen gets further, like that part of the molecule gets further oxidized because you have a giver of oxygen here. It can give it right there. And so what does that become? And that's the answer. Carboxylic acid and ketone. All right, that was our first one. Good with the method so far. We're gonna try it again. I have space for more. Let's take a look at another one too. What about this one?
I do.
Do you?
Yeah. Oh my gosh. Do you need the paper? Okay. And that was with me putting multiple empty pages, right? Yeah, sure. Some of the lessons you'll see that I do 2 slides per paper, that's when I know it gets real. If you see 2 slides per paper, which I didn't do for this lesson, but I may have should have, that means that you need a lot of space for whatever you're doing. Alrighty. Like this, right? You get, I'm going to expand it out a little bit around that double bond. So you get C, H, H, and then that's going to be an O. I'm just pausing to give a different color. And then C, H, CH3. And then I write the O on each side. O, O. Now what? Any more O's? Every
A lot
H
of O's.
connected to that carbon gets an oxygen, right? O, O, O. What is this? So what
Public
is this?
intoxication.
Oxygen intoxication?
No, public intoxication.
Public intoxication. Too much oxygen? So
No,
this is
too much alcohol.
too much alcohol. Carbon dioxide and what is this? A carboxylic acid. So your actual product would be this and this would be what you would want to write. If you want to write H2O as well, this is H2CO3. H2CO3, you were supposed to memorize breaks down to water and CO2. If you want to write the water, I don't think there's anything wrong with it. If you want to write it as an additional product, but it's not an organic product. Yes? The circle part is the correct answer.
It's carbon dioxide, but.
Carbon dioxide.
Right. So
It technically makes carbon dioxide in water,
you could just write it as carbon. Oh yeah, but it's usually done.
but it's in water.
So it
So-
doesn't make sense to just.
Why write water?
Right. That makes sense.
Because you started with water.
Right, but
I
you.
don't think they count off for it, honestly, like just to understand that your atoms balance.
I mean, it's better if you just go with H2CO3.
Yeah, but you have to know to break it down, right?
Oh, so you have to
You
break
have to know to break it down. We learned that back in Unit 3, right? Every time you get H2CO3, that's not what you make.
You get
You
that.
make water and carbon dioxide, which is why it's so confusing the way it's presented. You're just like, hey, where'd that come from? Like, what? Where did it come from? So you gotta understand the process. So, I wanna do one more because you should see something spicy. Everything I've given you is like simple. So let's do one more. That's a little bit more spicy. Here we go. So, here we go again.
What?
I don't know what you. Cyclobutane.
You gotta figure it out. I'll give you a little bit of
Cyclobutane.
What's wrong with it?
Oh.
It's cyclobutane. That is not a box. That is cyclobutane. I could start putting meters, but I'm not going to. What would you do? Think about it. See if you get the right answer. Try to think of the answer.
Ben, are you a child? Why is your big road about?
I mean, you're technically all children, right? Unless you're 18.
There you go. That's my answer.
Well, you're safe from Texas for now.
Some of you are like doing the same thing, like dual enrollment and stuff. I was in like my second year of college, and I was still a child. You're technically in college in school. Learning college.
Really? That's weird.
Look at those. You got carbons all over the place again. Where are your hydrogen?
I don't want to draw them very fly.
That's a great question. All right, so let's go over it. This is a very fascinating reaction. There are other ones like it, and it is not I repeat, this is not outside the scope of what I have seen on both paper 1 and paper 2. So let's see what happens. We got an alkene, don't we? So you would break right there. But you don't break that because these are still connected. So what this does, this is called a ring opening reaction. Meaning instead of having 4 carbons now in a ring, you have them in a line. Yeah, it turns it
You
into
just split it right down the middle?
straight line. Yeah, you split it right down there. And now you've got 1, 2, 3, 4 carbons to write. So let's see if we can do that. And I'm going to tell you my strategy, which is the lazy way. So I'm going to go like this for now. Watch this. 1, 2, 3, 4. Still 4, no? But they're in a line.
Wait,
Right? I just went.
You just separate.
I just went. Now what's the next step of the process? It looks terrible. I'll show you the way that it should look, but this is the way to visualize it. O and O, right? This looks like something that's getting chopped. What now? No. What's on
So
this
we got
carbon right here?
carboxylic acid, 2 carboxylic
Isn't
acid.
it?
Oh, it makes those what?
Oh, they're still connected?
Okay.
And now what? OH. OH.
So
So how would the final answer look for most people? Like what would they write? 1, 2, 3, 4, right? And then this is a carboxylic, and this is a, and you get a dicarboxylic acid. Dioic acid.
wait, I got this. Here, my
It's called a ring opening
Wait, this-
reaction. You count the carbons in the ring,
my
you split it, right? Yeah.
wait, see,
I'll take a look.
and then O here, right? But it's, you have to, these 2 you have to connect here. That's what you do. Yeah. Oye, la falta de respeto de esa cuál es. ¿Cuál es la falta de respeto?
Hold on, let me get Sophie.
¿Cuál es la falta de respeto?
Yeah.
¿Cuál es la falta de respeto?
Yeah.
¿Cuál?
All right. What's the question? They're not part of the double bond breaking. They're already full. Like, that's not the, this is the reactive site. It's a good question. This is the only reactive site. Alkenes themselves do nothing. So if I've just got a plain CH2, it does nothing. Yes? That's why the CH2s here do not also become OHs.
No.
Yes? Good questions. No, please ask.
Wait.
Your question, what? Question.
What the hell is that?
1, 4 butadioic acid.
So you'll be out of those?
Yeah, these are both correct. There's certain different ways. Isn't this the same thing? It's the same exact thing.
So if we just make a broken box, is that count as correct? Or?
Yeah.
Right.
You just gotta remember what to do. Broken box.
Is that all your stuff?
So what it is, isn't it?
You want to try one more? Step up one more level.
Yeah. Sorry.
If I step up one more level, then we'll stop here and we won't do alcohols today. Is it sad? They'll get their own love. I told you there was a day in the schedule. I was just gonna, because it's the same technical reaction. Like, same thing happens, same idea, but we'll do it a different day. So let's do one more example here, and then I'll tell you the alterations to your homework.
No space.
No space? Do you need a paper for this lesson?
You should.
I'll give you a paper. One last one. One last one. Let's see how you feel about it.
Yeah, but
All right, one more practice question, and then we'll spend the rest of the time.
It's close. I still think gray is my finger.
You need paper? Do you have paper? You want paper? Go back to rewrite it, maybe? Okay, last one. Here we go. Stepping it up one more notch. Here we go. See if you can do this one.
What? Oh wow. What? No.
That's like another good thing. What is that?
Now we gotta do the longest one. 1, 2, 3, 4, 5, 6, 7.
Are you doing the next?
You're excited.
Seven.
Oh, no, I mean like in the box.
Oh,
That was not box.
Oh, well, that's not too serious.
Oh, no.
yes, that is.
Box. I'll put the product at the bottom. All right, try yourself first.
Oh, okay.
I've never seen a question like this on the paper too, but I have seen a question like this on the paper. One. So future bell works, just FYI. Yeah, they don't usually make you draw it by scratch, but they ask you to analyze it by looking at the products like
So,
that.
are we doing the build on it?
This is the last question. Had to end on a spectacular note.
This is fun.
Is there 11 preference there? 11, part 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Hakeem, I have your notes from last class. Hakeem, I have your notes from last class. And I'm not okay, let's go with one from last class. While I'm waiting for you to try it yourself first, I'm giving you, don't lose this, write the word Tuesday on it. These are the notes for Tuesday.
I mean, it's open.
Don't lose this, write the word Tuesday here, this is for the lesson Tuesday. Don't lose this, write the word Tuesday on here, this is for the lesson Tuesday. Don't lose this, write the word Tuesday on this, this is for your notes on Tuesday.
At this point, just record yourself.
Write Tuesday on here. Right, Tuesday.
That's not this
So,
side.
you know, for the
No.
Tuesday, that's the-
Oh, that was the other side? I thought there was the other side.
It was this, it goes
Tuesday at
in.
the top, sorry. Write Tuesday at the
It
top.
was soft.
Tuesday at the top.
That hurt.
Right, Tuesday at the top. Tuesday. This is for Tuesday's lesson. Right, Tuesday at the top. When I pre-recorded.
I know where.
Right, Tuesday at the top.
I
Right,
always.
Tuesday at the top. Right, Tuesday at the top.
Yeah.
You'll see me
It's the
Thursday.
same thing.
I'll review some of the stuff from the
You have
lesson,
ribs all
but
around
you
your
still
body.
need to read the notes fully. And then Mariani, tell Janie, right, Tuesday on this. This is for the lesson. For the lesson amount. You just have to take the notes. All right, how we feeling? We got it?
Tuesday.
Yeah, Tuesday. I have the egg puzzle already done.
Oh,
It'll
you
auto
guys-
post.
oh, yeah, you're not gonna be here on
I won't be
Tuesday.
here Tuesday, but the notes are there and I recorded the full lesson. I'll be there on Thursday to do the mechanism that goes along with the reaction. That's why you don't have a mini assessment, to be as fair as possible.
David, don't touch my pencil.
Yes, you ready?
You're not, David.
One pencil I have. What?
I built switch table.
I'm not done. I'm not done.
Couple things off.
This is the ketone.
You have to see
Okay, I'm done.
This.
First, you're gonna have to get your book back out of it.
Well, first I did the I did
Wait, you're gonna have to open your whole thing. Get the door back. Get the door.
I can't.
All right, I'm gonna go ahead and go over the answers so that you have it. And you can use the remainder of your time to study. So I need your full attention for just one more minute, I think. So here we go. Do what breaks up first. This
No
breaks
trouble
up.
with that one, buddy.
What does that become?
No trouble with that one.
O and OH. That's one product. That takes care of
What do we get?
that.
That's a chromosomal gas, right?
The other thing here, you can take off right there.
Yeah, that's what
That's a carbon with 2 hydrogens. So that means that one of your products is CO2, right? Now we got to deal with this thing, which is what all of you actually went for first that I saw, but I went for last because I picked off all the other stuff. And I was like, okay, this is what we're left with. So what are we left with? We're left with this. I'm going to go like
What do you get for the big product?
this,
This.
like that, right? And that. So far, so good? That's my step 1. Now I'm going to add my oxygen. Boom, 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 boom.
How do you get the CO2 and the?
There you go.
Because
Now
it's
done.
these 2 hydrogens.
It's all part
It
of it.
is OH, OH, and this, which is the carbon dioxide and water, right?
Oh, yeah.
Technically. Anytime you have a by the way, anytime you have a terminal alkene, meaning it's at the end, it's always CO2 is one of your products. Always. Because that
Oh, and
always
then you
happens.
also- And then you got the carbon.
Wait.
Now, I'm not
Either
done.
way, I actually got it right.
I'm not done. This is not right. There's a hydrogen here. So that's supposed to become a OH, right?
Nah, but I'm
Is there any other aldehydes that we gotta turn into carboxylic acid?
O's.
This and
I'm just that good.
that's it. 3 carboxylic acid is a ketone, and then the carboxylic acid got broke off on its own, and carbon dioxide and water. All right, that's it. You get a 5-minute break, brain break, or you get 5 minutes to quickly review the other lessons
5 minutes.
because the
Or you
next
get your
quiz
money
is
back.
starting in 5 minutes. Your next quiz is I told you today.
Really? I did
Aligned?
Shut up.
We'll practice more. Not on tape. On a paper 1 for sure, it can show. I have not seen one like that on a paper 2. I've seen simple rings, like the cyclobutene I've seen, but nothing more complicated than that on paper 2. Multiple choice, yes, I've seen it.
I got on my head.
All right, 5 minutes to brain break or to look over your flashcards or pray.
Oh, bro.
Who's not an atheist? Pray for it. You're meditate.
No.
Oh, there you go. Why did Mr. Clavell? Because like last year he told us, oh, if you don't believe in God, like I like that. Before the camera exam, just pray to me. Oh, okay. Mr. Clavell, that's funny.
No,
I'm gonna remember that next time I see him. He has not been here very much lately, but this week has been crazy with that. A lot of people sick, I guess. Like actually sick. 4 days.
What is this on?
I texted her yesterday. Everything up through last class is last semester. So that means addition of alkene, substitution with alkene, free radical substitution, and polymers, and forming alkene. Everything except for what we just
I
said.
remember catalyst.
Red. You should know this.
Everything is wonderful. We're in a great place. When the timer's up, you put everything away and go 1 per table. The quicker you do that, the quicker you, the more time you have to take the minutes.
Yeah, do this.
Remember you get
Oh, yeah. Dehydrate. You take the H and the O. Wait, no. Oh, yeah, show me the arrows. The arrows. Yes.
Oh, wait. Oh, okay, I get it. It's because the H will always be negative. No, it'll always be positive because the halogen will take the other elements. I know that. I can see that.
Oh, okay.
Very much. So when you have something like
Like big,
Bye. Have a good weekend. Thank you. See you next week.
HBR, right? So mechanics
You got a couple of minutes. By 2:05, you want to make sure you're getting organized. Wait, I thought.
but the stock market.
Nothing you need to know.
I'm studying. Yeah.
2 more minutes right now. 2 more minutes.
Are you studying?
Ignore my shit hazard.
It's not working. My internet is not working.
Getting ready. You'll get these back next time I see you, which is next week. Just like last time. We give them back the next class period. So you can see them, review them, so on and so forth.
And then the one on the inside gets
Yeah.
Do you have any proof of this movie?
Why? Just don't worry about it until.
I just thought they were trying to do it. Stability.
How do I fall sitting down, Damani? These are all questions. You're on my whole life, though. I mean, like from middle school to high school.
All right, at this time, it is 2:05. Everything you made, go to separate tables. Last year I did 15 questions, 15 minutes. This year I'm giving you 10, giving you a little bit more time. Bit of a rest. I know your brains are a little tired today.
Like another 30 minutes to leave, and I actually stay for 3 hours.
Future you in May? When you have puberty?
So you look between that.
I don't week. Future you.
You can enjoy the present. Just ride the
The thing's starting right now.
I'm waiting for you all to look at this point. Get rid of your notes.
David!
I don't know. I'm gonna be honest.
This is my pink.
No flashcards.
I'm just gonna give
Get
it.
into position. The faster you move, the faster we can begin.
And me.
I'm serious, I don't have it.
Alrighty, let's see if you were paying attention.
Yeah, but you should have been paying
I'm about to pass them out, so everybody please make sure you're at your seat and that you have no notes out. No flashcards. No flashcards. They are notes. There's a definition of notes. Alright, I'm going to go ahead and pass it out now. Good luck. You've got the rest of class. It is out of 10 questions. My anticipation is to do all of them out of 10 points. And so when you get a score, it'll be somewhere between 0 and 100. Alright?
You should